If you have any questions about the day, where a session is or where the bathroom or cafeteria is, I can help you with that. And I would like to introduce Ty, who will be talking about the inside the competition season of Team 2056.
Welcome everyone, thanks for coming. So yes, today we're going to be talking about the keys to success that our team has found over the last number of years, and things that we do that we would like to share with the community as a whole to help to bring everyone up. So this presentation is very similar to what I've given the last couple of years. I see some familiar faces in the crowd, but we have updated it for what no bag means for us and a few other things. So to get started, who am I and why are you listening to me? My name is Tyler Holtzman. I'm the lead design mentor for 2056. I was a 11-14 alumnus in 2003 and 2004, returning mentor until 2007 when we started in 2056, and I've been here ever since. My professional career, I'm a design engineer for Holtzman companies. We build robotic systems for the food industry. So grippers, end-of-arm tooling. We do a lot of what's called palletizing, which is you buy a box of something at the grocery store. That box got shipped there on a pallet, so it was stacked on a big-ass pallet, so a forklift driver can pick it up. So we build robots that can pick up boxes and stack them on pallets for shipping. So I do a lot of grippers and end-of-arm tooling and robotic stuff, and pretty much this bigger for a living. In 2010, I won the Woody Flowers Finalist Award, so that's me. A little bit of outline of what we're going to talk about today. We're going to start off with goal setting. Then we're going to lead into our build schedule, including what changes we're tentatively planning to make in the no bag era. Then we're going to talk a little bit about how we make decisions that steer our design on this team. Some design methodologies, which is like the basic theories behind how we start off with a concept and end up with something that looks like that. And some fabrication and assembly techniques that we found work for us as a team. If you have any questions along the way, please stop me. Just throw your hand up. We can talk about whatever. This doesn't have to be a formal thing. Just interrupt me whenever. It's no problem. Okay. Now, we're going to start off with goal setting. So we're really big on setting goals for lots of things. And those goals are going to be what drives your direction for a season or an event or a week or even like an individual day of build. So we usually start really big with a season goal and then work our way downwards. So our season goal for the last number of years has been to win a championship. It has not been to win the Waterloo district. It is, well, it's kind of been to win provincials, but for the most part, it is to win a championship. And if winning a championship means sacrificing a district, then that's okay. You don't have to win every match, just the last one you play. Unless you don't make limbs, then it's just a bad thing. But so we start really big with our season goal, and that's to win a championship. Next might be a goal for an event, which is going to be different for every team, and you guys got to figure out what your goals are and what you can do to maximize your success. So for a lot of teams, a good goal might be to be competitive on Saturday afternoon. So they want to go to their district event, they want to be playing, and they want to be competitive in the elimination rounds. They want to participate in the elimination rounds. But maybe not everybody's goal is going to be to win a championship or win provincials or to do whatever. So setting goals for that, for whatever it is that you're doing, is going to drive your direction. So, for example, if your goal is to be competitive on Saturday afternoon, you're not going to try to build a robot that's, finishing rockets and climbing to level 3 on their own. Maybe you want to build a robot that scores on the cargo ship, or maybe you want to exclusively do cargo. Those are valuable skill sets that any alliance is going to want to have, on their alliance. So those are things that you can do to get yourself picked that, reduce the overall complexity of your design. So a little bit later on, we're going to talk about building within your resources and how you can maximize your performance even with relatively few resources. For most teams, we are not a great example of how to operate. And the reason I say that is over the years we've amassed significant fabrication and design resources that allow us to build very, very cool and competitive robots. And if we did not have those resources, we would not be designing the robots that we do. We would do something much simpler, much easier to fabricate. So think of your own resources while we're talking about these things. So we set goals for everything. Later on when we talk about our build schedule, I'm going to talk about what our goals are for each individual week of the build season, which is not really a build season anymore. It's just this 4-month-long marathon, March of Death. And even down to like individual days of build. And we've been pretty good the last couple of years about sticking to our schedule, which if you've never seen it before will seem outrageously aggressive, but we find that that's what works for us. So we start big and work our way down. I would encourage you all, before the season starts, to sit down with your teams and figure out what your goals are for the season and then work towards them. Questions on goal setting? Okay. Focus on the little things and the big things take care of themselves. This is a quote my old bike racing coach told to me and has stuck with me for a long, long time. And the gist of it here is there's a million little things that can drag down an FRC season. And if you can focus on nailing those little things, then the big things, kind of take care of themselves. I thought this was good. No more questions on goal setting? In first, it's perfectly reasonable to have a goal of, I want to be competitive on Saturday afternoon. There's nothing wrong with that. And there is no team in first that could not achieve that if they, plan and say, this is what we want to do, and then they go out and do it. There's, with the most basic hand tools and no engineering technical background, all teams should be able to do this. Okay, moving into build schedule. Traditionally, this is the schedule we've gone with in the old bag era. So during the build season, which runs this year, January 6th till the end of April. This used to be January 6th until bag day, but we would meet Monday, Wednesday, Friday, after school until 9:30, and Saturdays from 9 to 6. So 4 days a week. 4 days a week for very solid time periods. We don't meet 6 or 7 days a week for 2 hours, because in those 2 hours we find we get in, we set up, and then it's time to clean up and go home, and then you never get anything done. So we found that switching to a more divided schedule where we only meet 4 days a week, but we meet for solid periods of time for each of those, that worked a lot better for us, and we were able to be more efficient than when we were meeting 6 days a week. We made this switch in, I want to say about 2015, and prior to that we met Monday to Friday, 2:30 to 5:30, except for Mondays and Wednesdays when we'd stay late, and then Saturdays were 9 to 6, but the shorter days we just didn't get anything done, or were just unproductive or whatever. So we switched to this more Monday, Wednesday, Friday, Saturday schedule, and that worked a lot better for us. It was easier to manage for kids because they got days off in between where they could do their homework. It was easier to manage for mentors who are coming from work and can't get here till 5 o'clock anyways. So we found that worked a lot better for us. And it works out to about 30 official hours at this facility a week. Which may seem like a lot to some teams. It may seem like not a lot to others because there are a lot of other very competitive teams that meet twice this much. And I think they're crazy, but hey, it works for them. So the big thing is here, as you guys as teams have to find a schedule that works for you, works for your students, works for your mentors, and then stick to it. And when you're designing your robots, know how much time you have to do the things that you're going to do, and then build within them. Now this is 30 hours officially here. Behind the scenes, there's probably another 20 hours a week of design that happens outside of this facility, or maybe we make a list of parts to get ordered or whatever, and I do that at my office while I'm at work. I'm supposed to be working. But behind the scenes, there's a fair bit more that happens. But that's a lot easier to manage because we don't have to be here at the school. And I've always found that finding ways to be efficient without having to be here is really important to, spending time, having the extra day in between the Tuesdays and the Thursdays and the Sundays, the days in between the days that we're meeting to get organized for the next day goes a long way to maximizing your productivity when you are here and we do have the machine shop and we have the CNC and we have 30 kids all raring to go and wanting to make stuff and do whatever. So that's kind of what led to this general build schedule. Find a schedule that works for your team. Your mileage may vary. So again, every team's got to figure this out for themselves and figure out what allows you to meet the goals that you set, but not burn everyone out. Because that, mentor burnout is the leading cause of teams that no longer exist anymore. Questions on build schedule? No questions on build schedule? Okay. No more bag. This is a big change. This is the first time in, ever that we get to keep our robots, which might seem crazy, or the whole concept of the bag, if you come in from outside of this group, you're so wait, you build this robot and then you gotta seal it up and you can't work on it until you get to the event, but it might not be for 4, 5, however many weeks later. The whole concept is crazy. So they got rid of it. So, no more bag. What does that mean for us? Honestly, not a lot. Our schedule will not change significantly. You'll notice we have a robot there. That is our competition robot from last year. You'll notice there's a robot sitting in that corner that's a disassembled pile of stuff that is pretty much identical to that thing. So that is last year's practice machine. We will still build 2 complete robots. There are no major changes to our approach to robot build, or at least none planned, other than a slightly relaxed build schedule. So when we get into our build schedule, you'll see, if you attended the presentation last year, that a lot of our dates are shifted back by about a week. And we'll get into that in a bit. And we have no plans to build a sort of secret championship-only robot. Do we? I don't know. Probably not, because I don't want to die. But yeah, I don't think it really means a whole lot for us. On the same token, if you get the approach completely wrong and you get to week 1 and realize, oh my goodness, we've built this thing that's a monstrosity, you can still rebuild. There's still time in the schedule to do that if you choose. And making big mid-season changes will be a whole lot easier this year. I would caution the majority of teams against it, unless they really get it wrong. But yeah, it probably will not mean a lot for us. Ask me that again in 4 months. You may get a different answer.
Tyler.
Yep.
With the no bag coming, how many teams do you hypothetically do you think might screw up and per se make their schedule too long and then screw themselves over?
Yes, absolutely a lot. I think a lot of teams over, we're not competing until week 4. We don't need to get the robot done until week 3, and like get it to week 3, and then we don't have autonomous mode, and it'll still be exactly the same thing. So when we get into the schedule, I'll talk a little bit about the differences between the tentative schedule we have planned and what we would have previously done, and you'll see it's really not all that different. Which kind of scares me at the same time, so I don't know. This season is going to be a learning experience for everybody, and we'll have to see how it goes. More questions on schedule? Yeah.
Why are you still doing the second robot? What's the benefit now?
Our practice robot sees enough runtime in its life that it would be non-functional by like week 4 of districts. So if we only built one, it would be worn out before we got to our first event. So we'd end up building another one anyways. So we just planned to build 2 and then only use the one for a very, very restricted runtime compared to the practice robot that sees hundreds of hours on it before we get to our first event. And that's another thing that I think teams will maybe overlook is they'll build their robot, they'll get it running, they'll do weeks and weeks and weeks of practice, and then they'll get to their first event and the thing will break down every match because it's like so fatigued already that the majority of teams in first do not have the experience with longer run times.
I was just about to ask running that.
The last 3 years, almost like clockwork, our drive gearboxes have worn out in week 5 of districts on the practice robot. And the competition robot, almost like clockwork, the drive gearboxes will wear out in about November. So we're still going to build 2 just so that we have longevity in the one, and that we can have 2 operational robots for one to do driver practice on this end of the field and one to do autonomous on this end of the field, or vice versa, or things like that.
Are there any certain precautions that you guys take when designing to try and prolong the life of a machine? Anything that would be typically, or atypical of a standard FRC team?
Care during assembly goes a long way, making sure that you remember to grease gearboxes properly, making sure that you assemble your versaplanetaries properly. The versaplanetary gearbox is an incredibly versatile and useful COTS item. And the majority of teams that have problems with them are ones that are either grossly exceeding the load ratings or just not putting them together properly. But if you abide by those 2 things, they are fantastic gearboxes that can be used for the majority of mechanisms on your robot. We had 3 on that one, and 5 on last year's. We almost never build gearboxes anymore, which for most other teams on our performance level seems crazy, but we don't have time to build gearboxes, so we just buy the ones that work and then use them, and they work good. So care of assembly and care of assembly. A lot of the gears and stuff that we use are aluminum for weight, and that doesn't help. Like you're using something that's intentionally really lightweight and light duty cycle, and it wears out. So if you know that it's going to wear out, then you can preemptively sort of rebuild your gearboxes and swap your gears out. And we've done that before. So that's something that it's going to catch out a lot of teams, I think. More questions on schedule before we get into the nitty-gritties? Okay. So, what week 1 of our competition season looks like, and this is exactly the same as it looked in the pre-bag era. Saturday of kickoff, we meet at the Stony Creek Library, which is just down there. And we, sit all as a group and we watch the broadcast, and the big thing it is to completely read and understand the rules, and then we kind of establish some constraints, scoring challenges, and then we order game elements. That is the first thing that we do as soon as the manual comes out. We order a boatload of game pieces. Because nobody likes waiting until Monday and going to order your game pieces and Andy Mark's out of stock. So order your game pieces right away. You know you are going to need them, so just do it. And that's pretty much it for Saturday. It's really not a huge fanfare or all-night marathon. It's just, let's read and understand the rules. Take them home with us on Sunday. We don't have any formal Sunday meeting on the, at any time during the season. And we just read and understand the rules, and that's it. The Monday of week 1, we come in, we'll meet in this room, and our whole team will sit up here, very much like you guys, and then we'll look at the game. We'll look at the ways that we can score points. We'll identify things we need our robot to do, not necessarily how we're going to do them, but just things that we need it to do, and identify any trade-offs if necessary. There are certain years where doing X excludes doing Y. So if you want to do these two things at the same time, it's very, very difficult, and sometimes you have to pick one or the other, but not both. Some years doing everything is necessary, other years it is not possible. What is a game in recent years where doing everything has not been possible? Or at least not a good idea?
2013?
Yes, that is a great example. That is a great example. So 2013, for those of you who weren't around, was a game where we were shot frisbees. So the robots would either pick up frisbees from the human player, or would pick them up off the ground, and would shoot them through this big hole in the player station wall. In the middle of the field, there were these two big pyramids, and the robots that could climb to the top of the pyramid would get big endgame points. Or you could just climb on the bottom of the pyramid and get like a little bit of endgame points. So the two big tasks that differentiated a lot of teams were teams that could pick up discs from the floor during the autonomous period, which gave you a huge scoring bonus, and a qualifying advantage, because I think the first tiebreaker was auto discs. And then the teams that could climb to the top of the pyramid would also get huge endgame points. But picking up off the floor and climbing up the pyramid were two very, very different scoring challenges, and to my knowledge, there was only one team that could do both effectively. They're not very good. It's 254. Anyways. And it took them until week 5 or week 6 of regionals to actually get both subsystems working competently. And I think they still would have been better had they just picked one or the other. But the majority of other high-performing teams chose one or the other and did it well. There were a few teams that tried to do both and ended up scrapping one or completely redesigning the robot. The Robonauts, for example. So anyways, the other thing we tried to do on Monday is decide on the drive base that we're going to use and order components for it. Do we have? No, we don't. 2016. 2016 game came out, and the 2016 game involved driving over these big obstacles.
Yeah, 2016.
Oh, yeah. Do I have 2012? I don't have 2012. So in 2012, there was this big step across the middle of the field that you had to drive over. And we built a drivetrain that had 8 big air-filled wheels, and we could just fly over this gigantic bump in the middle of the field. So when the 2016 rules came out, we kind of looked at it and said, hey, this drivetrain that we built over here, this one worked great. Why don't we just build that again? Nobody really had any objections. So we ordered the wheels for that robot on Saturday of kickoff. And by Tuesday, they were all sold out. So all these teams that tried to get wheels after the fact were stuck until like week 4 or week 5 of build season that year. It meant that they didn't have driving robots until it was like time to go in the bag. So sometimes it's good to make decisions early and then get the stuff and then you've got it in your hands, because the first community as a whole is fairly small and we have a limited network of cost suppliers, commercial off-the-shelf components that can sell for specific wheels and gears and whatever. So if it's a limited stock item like that, it's important to get that on order as soon as you can. Although with the whole no bag thing, that will probably impact teams a lot less, but it's tough to make revisions to your robot if it doesn't move. So yeah, get your wheels on order. And then once we've decided that yes, this is the kind of drive that we want, we typically start designing the drive base first. And we usually start with a kind of ground up approach. There are times when your scoring mechanisms impacts how your drivetrain looks, and then later on when you get into weeks 2 and further into the design process, then you have to look at how to integrate those two things so that they play together nicely. 2016 was a good example of that. Our shooter, you can't really see it, I wish I had it down here. Our shooter, the whole ball went through like the middle of the robot, so the electronics were like up on the sides inside the chassis. And the whole robot was very compact. That was less an exercise in design and more an exercise in packaging, jamming everything into like the smallest possible space. So that's what Saturday and Monday looks like in week 1 for us. So by the Monday, we've kind of decided the robot's gonna have, I got no markers. The robot's gonna have 6 wheels or 8 wheels. They're gonna be air-filled wheels, or they're gonna be treaded wheels, or they're gonna be Holtzman wheels, or they're not gonna be mechanical wheels. No. So yeah, we've got the bottom half kind of figured out of what we want. We know whether it's gonna have a shifter or not. Yeah, that's pretty much it. Questions on the first couple of days? Wednesday, week 1, we continue brainstorming and we want to decide on upper mechanism layout. So we're figuring out, I really wish I had markers.
There's one behind the eraser.
One behind the eraser?
Yeah.
So on Monday we figured out that. That's what we figured out on Monday. By Wednesday we figured out that. And that's kind of what it looks like on Wednesday. It's literally just a graphic sketch. Maybe we lay some stuff out in 2D, like a side view of the robot, to make sure that this gripper is actually going to fit here, and that when this thing folds out, there's not a pulley cord holding it closed. Just figured out some very high-level stuff to know that, yeah, the robot will package the way we're expecting it to package. Exactly how we're going to do all that is another story altogether, but just a very, very general conceptual layout. Yeah.
The drivetrain between last year's robot and the previous was extremely similar.
Yes.
With the exception of the number of wheels. Maybe why we made the decisions we did in the number of wheels.
Yeah, like when we started brainstorming this past year's machine, there were immediately parallels drawn to the previous year's machine, which is over in this corner. And if you put the two of them together, aside from these gigantic forks sticking outside, and the gripper being different, the robots are almost the same. The general chassis layout, very similar. The gearbox is exactly the same. The drive gearing, exactly the same. The elevator layout, very, very slightly different. The back of this guy was built a lot more rigidly because we had the little wheelie bar that comes out the back, whereas the back of this one is much lighter duty construction. But generally the robots were very, very similar. And we drew on a lot of experience from the previous year's chassis when laying out this one. So we had two games that had very, very similar manipulation requirements in terms of the heights of stuff. So that's what led to these two being very, very similar. They both started off as 8 Holtzman wheels. They both finished off not as 8 Holtzman wheels. 2017, we ended up removing, or almost removing, that wheel altogether and replaced this one with an Omni wheel. And the reason behind that was the robot drove great when the elevator was down, but oftentimes scoring on the scale, you had to maneuver a little bit while your elevator was way up in the air, and the robot just drove terribly while the elevator was up in the air. So by ditching this wheel and changing this one to an Omni wheel, we basically just drove on these two wheels all the time, and this one was like not even touching the ground, unless we like accelerated really quickly and the robot rocked back. So this gave us this nice stable platform for maneuvering with our elevator way up in the air. Last year's machine was not like this. We ended up leaving these two wheels in place and ended up swapping the outside corners for Omni wheels. And the reasoning behind that was you didn't do a lot of maneuvering while your elevator was way up in the air. So we wanted a more maneuverable platform for driving around while the elevator was down. And with a layout like this, your turning center is right in the middle of the robot. You have good agility side to side. It doesn't drive as well with the elevator up in the air, but that wasn't a big deal. But it gave you a better handling chassis for driving through defense with the elevator down like this compared to this wheel gone sitting on these two wheels. Because the 2017 layout, the turning center is back here. Yeah, the robot's more solid on the ground, but it's kind of a little more lumbery while it turns. You want your turning center to be as close to your center of gravity as possible. And RCG was like up here in 2017. So you've got this big moment of inertia that you're having to turn around to try to maneuver your robot. So if you can keep the turning center as close to the CG or directly under the CG, ideally, your robot will handle a lot better. That's kind of one of the little hidden details of drivetrain design is the distance between your turning center and your center of gravity. I could give a whole talk on drivetrains, but that's not what this is about. So back to week 1. Wednesday we're continuing brainstorming. We're deciding on an upper mechanism layout. We're prototyping as necessary. Our prototypes are terrible. They are usually like really, really hokey things just to try to figure out will a roller work well to pick up this ball, which is always yes. Will a suction cup work well to pick up this other thing, which is almost always no. They're usually pretty janky prototypes that don't really tell us a lot. If we're trying to figure out the exact geometry of something like 2016 is a good example. We had this robot with bumpers on it, 8 wheels. And we had this little arm that came out the front, with a roller here and a roller here, and the ball would kind of like roll up and over and into the robot. So we built a little wooden mock-up of this to figure out the position of these two rollers relative to the front bumper to make that ball roll up and over into our hopper. And it was just 2 pieces of plywood with 2 rollers off of some old robot and a couple of cordless drills. And it was very, very cheesy, and we spent dozens of minutes on it. And it's just enough to figure out a proof of concept. We're not building, whole wooden mock-ups of our robots and driving them around. No, we're not doing that. As we firm up more of the design, we order more stuff to make sure that we get the stuff before it runs out of stock. Those green wheels that's on the gripper for that guy, those things went out of stock at the end of week 1. We had ordered 100 by that point, so we were good. Continued detailed CAD design, and Saturday at the end of week 1, we meet in this room to build the field. And we have an army of parents and an army of kids, and we build these wonderful rockets. The other one is demoed. The cargo ship was like a pile of sawdust, so it's gone already. But yeah, we meet here and build all the platforms and stuff. That's the Saturday at the end of week 1. Questions on week 1? Week 2 is all about detailed CAD design. Yeah, that's pretty much it. We're prototyping as necessary, and by this point, if we have enough of the drivetrain CADed, then maybe we'll start some fabrication here of the shafts that go through our wheels and spacers and stuff like that, other than in-house fabrication that we're doing here. If you get a chance later on today, go look at the machine shop, which is just down that hall on the left-hand side. We have a small CNC mill that we make a lot of stuff on. It runs pretty well nonstop from the time we start fabrication until the robots are together. Yeah, so week 2 is all about detailed CAD design and starting in-house fabrication. And we're also ordering any raw materials that we're going to need for our outside fabrication. So we're ordering lengths of tubing. We have our stock up there that's random pieces of tubing and stuff that's left over from previous years. So we're going to order raw materials we need. We know we're going to need 3 sheets of 1/8 aluminum. We know we're going to need 100 feet of 2x1 tubing or whatever that is. We're ordering that stuff in week 2 so that we can have it for week 3. And this is where the schedules from pre-bag and post-bag diverge. Because at the end of week 2, we used to have, or have historically had, the CAD is now done to the point that we can send everything out. But what we're going to do going forward is we're going to push that back 1 week so that the CAD will go out at the end of week 3. So that gives us a whole extra week of additional design time to try to better optimize the machine, make it lighter, make it stronger, maybe examine other design possibilities. We ruled out the whole suction climb thing very early, which was foolish. We should have put some more thought to it. And that was kind of the one thing that that machine was lacking, was the ability to climb with a partner. So having that extra week to examine some of those other possibilities, I think will probably help us. But at the end of week 3, our plan is to release drawings for outside fabrication. And when I say outside fabrication, I mean we have 2 major outside fabrication sponsors. One of them is Westbrook Greenhouse Systems, which may seem a little silly, but Westbrook Greenhouse Systems is a company that has, it's called a tube laser. Basically, it's this like 60-foot long machine that takes full-length pieces of tubing, and it's got a chuck on one end that holds one end and kind of feeds the thing through the machine, and it's got a laser head on the other. So it can cut out parts like this that are very intricate in one setup, and then they pop out looking like this, but a little bit dirtier and with a bunch more slag on them. Pretty well done. So all of the tubing on this machine was cut out in about, well, on this machine, that machine, and that pile of spare parts over there was cut out in about 3 hours. which is crazy if you actually think of how much work it would be to machine this stuff, traditionally on a router or a CNC mill or something like that. And the part quality is pretty good. I'll pass this guy around. So that's our tube laser sponsor, and they just do exclusively tubing for us. Our other outside fabrication sponsor is Barlow Manufacturing. And they're a big machine shop that has a gigantic laser and CNC brakes and the ability to do formed sheet metal components for us. So the tubing and the sheet metal is what goes out, and that makes up the majority of the big stuff on our machines. So a sheet metal component like that will get cut out of a flat sheet, and then we'll go to a brake press and get the flanges and stuff bent on it. And these guys are pretty good. If we send them drawings on a Sunday night, by end of day Friday, we usually have all that stuff back. It comes back raw out of the machine, which means it has a lot of slag and leftover cutting stuff on it, which means we have a big deburring party, which you'll see is the first thing on the end of week 4. We basically have an army of grade 9 kids with files and emery paper to clean up all these parts before we start assembly. So that's a great opportunity for new students to get involved with fabrication. But it's got to get done, so we put the army to work. So anyways, this is where the two schedules diverge. The release of drawings for outside fabrication will be pushed back a week, and then we expect to get those components back a week. And the whole schedule just shifts back a hair. Last year we were actually a day ahead of this. We released stuff at the end of week 2. We had everything back a little bit early, and then by the Saturday of week 3, we had a chassis together, a whole complete robot with no electronics in it, which was pretty awesome. We were quite pleased with that. So we were a whole day ahead of our typical schedule. And then, so the new week 4 is all about in-house fabrication. We get the stuff back at the end of week 4, and we begin practice robot assembly. Like I say, last year we were like a day ahead of this, but that's whatever. And then by the Monday of week 5, we aim to have complete mechanical assembly of a practice robot, no electronics in it. And at that point, we have like a rolling chassis together with no controls. We want to identify any areas of possible concern or rework. So will this gripper pick up a ball? Will this hatch thingy grab a hatch? Will our robot drive over this platform without bottoming out? Will we be able to lift the partner up with us when we climb on the scale? Things like that. So we do some kind of hokey testing just with like alligator clips and hot wiring motors to see, if stuff runs the way we think it's going to run. And if it's all good, then we wire the whole thing and try to get it running. If it's not, then figure something out. And we've been pretty good about having stuff generally work the way we expect it to work. So by Wednesday, we have a practice robot wired, and we throw whatever the software team has got on it. Did I skip that altogether? Yeah, back in week 3, we start software development. Yeah, determine initial control design and begin software development. So we sit down with the controller and we go, these buttons are going to do these things, and these are the functions that we want this robot to do. Now, controls team go design it. And we try to keep the previous year's practice robot semi-functional so that they have a test bed to develop that software on, and they can make something that drives and that kind of stuff. And last year was particularly handy because the robots were so similar and had such similar functionality to them that that worked really well. Am I going grossly over time here? No, I'm fine. So in week 4, we have a practice robot. In week 5, practice robot is functional, and we want to finalize the design prior to competition robot assembly. So we've got a practice robot that's got some software on it and it's kind of driving around. It's not completely integrated, but it functions enough to know that, yes, this is what we're going to build for our competition robot, or do we need to redesign the gripper, the forks, or the elevator is just not going to work like this and we got to do something else, or whatever that is. 2012, we had this turret shooter, and we built the thing, and the thing shot like a champ. It was great. It drove like a pig. So what we actually ended up doing was cutting about 1.5 feet out of the middle of the robot, and we dropped the shooter down a whole lot lower. And what that did was it brought our center of gravity down enough that the chassis drove a lot better. We were able to drive through defense and just be a lot more maneuverable. So that was one of the big sort of mid-build season redesigns that we did. And it actually turned out to be very little work. It only took like a couple hours, but that's one of the things we want to figure out in that sort of week 5 window is, do we want to change anything from this machine we have working to the competition robot, figure out what that is, and then make those changes on both. So new week 6, which is the old week 5, is about competition robot assembly, and we leave significant time to do this properly. I talked about care of assembly, making sure that your gearboxes are put together properly and things like that. We leave significant amount of time so that we can make sure that we do this right, that every nut and bolt is tight, that every rivet is seated properly, that every electrical connection is crimped properly. And we do that in one area. At the same time, we're doing software integration and automation on the practice robot, which has been functional for a week now. Functional testing, software integration. We're not doing driver practice at this point. We do not start driver practice until the robot is at a state where it can be driven in a competitive fashion. I personally don't see value in practicing before your robot is done because a bunch of stuff's going to change, so why build bad habits or things that you're not going to use anyways? So it's all about getting the machine functional right now. And the new week 7, which was the old week 6, by the Monday, competition robot is done. We're still doing software integration and automation on the practice robot, and we maybe start autonomous modes. So now we have 2 robots that are powered up, functional, driving around. We can do auto modes on one and software integration on the other if the sort of integration is far enough. Usually the auto modes rely on the integration working, so usually you can't do one without the other. And then Wednesday, Friday, Saturday is a buffer for unexpected delays. So if anywhere along the season we have gotten behind for whatever reason, this buffer is built into the schedule to allow for that. Previously, we would have been bagging the competition robot immediately after this. So I've got a note in here about competition robot shakedown. This is much less important to be doing right now because you have between 1 and 4 weeks between this moment in time and your first event. If you're competing week 1, you would have 1 more week. If you're competing week 4, you would have 4 more weeks. So where you're competing and when you're competing also has an impact on how this is going to work. And then we get into week 7+, which is the old sort of pseudo end of build. So at this point, we still meet Monday, Wednesday, Friday, Saturday for the majority of this season. We don't meet over March break. We will be competing at the tail end of March break this year. So during that time, we're doing practices here at lunch, practices after school. We're making design revisions as needed. So if we find that we can improve our ball gripper by doing X, Y, and Z, then we'll do that at that time. But the majority here is driver practice and making design revisions as necessary. So yeah, daily driver practice robot maintenance, which eats up a significant amount of the practice time. because of the extended run life. One of the big benefits of building a practice robot that's more applicable in the bag era than it is in the post-bag era is you find out all the little things that are going to break and wear out on your machines well before it happens in competition. And you can correct and address those issues before it ever happens on a competition field. Tournaments are won and lost by one poorly crimped wire. That's all it takes for your tournament to go from, blue banners and high fives all around to, going home feeling crappy. So, this will be less important as all of our competition robots see more runtime in the no bag era, but I think it's still of benefit. We will watch other events. We will attend other events if we're not competing. We often go to, we've been to a couple over the years, but we'll often go to a week 1 or week 2 event just to go and watch, see a competition field with your own eyes, learn all the weird little tricks that 1325 has figured out for jamming stuff through holes that they're not supposed to get jammed through. Things like that. So we're going to attend other events and look for areas to improve our machine. Questions on build schedule? Good. No questions? Yes.
Can I see the week 5 build schedule again?
These slides will be available afterwards. Week 5, which is the old week 4.
Okay, thank you.
Decision making. This is one of my favorite topics. Make decisions early. More time to regret them later. We're big on picking a direction and going with it. And we don't spend weeks and weeks and weeks trying to find a direction and then not having enough time to actually execute that. And I think that's something that a lot of teams struggle with. So the important thing here is that the initial direction that you pick is the right one. And that's the really tough part to get right. And there's nothing that I can tell you during this hour-and-a-half presentation to inspire you with wisdom. That's something that just comes with experience. So yeah, this works for us. It may not work for everyone. Figure out what works for you. We are a heavily CAD-driven team, which means we will design nearly every component in SolidWorks prior to fabricating anything. And that works for us because we have a group of design people who are very fluent with SolidWorks and who are very good at it. I use SolidWorks every day for my job. That's what I do. So yeah, SolidWorks works for us. We rely largely on experience. We've been a team now for 12 years, and some of us have been involved with First for longer than that, so we've seen a lot of things and done a lot of things and made a lot of mistakes and learned a lot of things along the way. So one of the things that every team can do, whether you're a rookie team or a seasoned veteran, is look to the past for inspiration. A lot of games draw very similar design constraints. So you can look for inspiration for ball grabbers from every second year, or hanging off a bar we've done I don't know how many times. So you can look for inspiration from the past, and there's other resources like Chief Delphi and Robot in 3 Days, and Build Blitz, and all these, whatever, build a robot in a ridiculous time frame and see how bad we are. Those kind of things that you can get inspiration from.
Have you guys on 2056 ever, is there a time you can think of where you have seen an idea or a design that you have gone, that is so blatantly exactly what we need, or like, you know, and steal from the best, copy from the rest, like, so, but blatantly, obviously. I'm thinking along the lines of, I don't know, like, taking Madtown's intake this year and all of a sudden every team pops up with it or something like that.
Can grabbers. Can grabbers. Our 2015 can grabbers were heavily inspired by 548s. Interesting history there. Go read the history books. So yes, that's one. Consensus, the other thing in our decision-making process is consensus versus voting. So we make our decisions based on consensus. We talk about things as a group and together collectively make a decision. We don't have, you know, the suction grabber versus the roller claw vote. We do not do. And the reasoning behind that is, should your grade 9 student first year and first, should their vote count the same for a 5-year alumni who's design mentor on your team? Like, they're two vastly different experience levels. So we'll discuss design decisions like that as a group, but we don't do voting. Know your limits and design within them. Our team didn't always have these elaborate fabrication resources. If you look at some of the older machines, they're a lot less intricate, a lot simpler. They're things that you could have built, in your garage with very, very limited tools. Our first machine in particular was built with no outside resources. It was also a very, very simple robot, and it worked. So knowing what your resources are and designing within them goes a long way towards maximizing your performance over the course of the season. So for example, don't design an elaborate sheet metal robot if you don't have sheet metal resources, because you're not going to spend a week, 2 weeks, 3 weeks in the season knocking on doors trying to find Joe's lasers to cut out your parts for you. That will turn out very badly. So design to the resources you have and build. Don't do everything! Exclamation mark. Doing everything is almost always a bad idea. Even for the most elite of elite teams, doing everything is almost always a bad idea. Last year, one team tried to do everything. Citrus Circuits. And they were pretty good. But they could have been better had they not tried to do everything. Because their robot was like so gangly and so lightly built to have enough weight to do all this crap that I think they could have been better had they not done everything. They built a robot. They could pick up balls, could pick up hatches, but could also like score them backwards through themselves. And they had these big wings that would come out so they could pick up 2 partners with them and climb, which only worked, I don't know how many times, once or twice, or a very select few times. So I think had they devoted the weight and the resources that they put in those into making their other mechanisms better, they would have been probably better off. And for the average team in first, doing everything is a horrible, horrible idea. You should specialize in specific areas. Last year we saw a handful of rookie teams in Ontario that specialized in just scoring cargo. And they were amazing. They were competitive. They competed in the elimination rounds of the provincial championship. They made it to provincials, competed in the elimination rounds of the provincial championship. And were very successful compared to other teams that tried to do too much and then were watching from the sides on Saturday afternoon. So know your limits, build within them. It takes a great deal of maturity to know what is too much for your team. But if you take that step back and you build within that, you will have a more successful season. Questions on decision making before I move on? Design methodologies. These are some of the basic principles behind how we design robots. So the first thing, actually the first three things, simple, simple, and simple. Now you may look at these robots and think that they're very complicated, and they kind of are. But if you actually break it down, this robot is simple. So we've got an elevator, it goes up and down. We've got a little wrist that goes, tilts this way. Our hatch mechanism was two little cylinders that open these little flappers, and two more cylinders that just, fire them off. And then our ball grabber was just a roller and a bar. We also had these kind of goofy wheels on the front that we used for climbing. So we had sort of integrated the climbing mechanism into the ball and hatch mechanism so that it was one, we could put our gripper out and then fire a wheelie bar out the back, and we could lift ourselves to vault us onto the platform. And then the wheelie bar is just, another set of tubes that slide on each other with a versaplanetary and a strap. And this just winches it down and pulls it down. Like, it was only driven down, it wasn't driven up at all. It just had some constant force springs that would just barely hold the weight of the mechanism up. This is a really simple way of designing a linear mechanism that only sees load in one direction. We've done this a couple of times. Our 2016 hangar was like that. It was sprung up, and then we would winch it down. I think that's it. The elevator was driven both upwards and downwards, because we had to vault downwards to lift us up onto the platform, and we had to lift the thing up to score. That's what I'm looking for. So the basic concept should be simple. If you have some elaborate concept where you're like picking up game pieces with one mechanism and then passing them to another mechanism that's lifting them up and then firing them out into a third mechanism, you may not have the best time with something elaborate like that. Robust. Things must be robust. Generally, mechanical failures can cost you matches. Matches cost you seeding. Seeding costs you tournaments. So there is no room for mechanical failures, electrical failures. There's really no room for failures of any kind, if that's what your goal is. So we're big on making things as robust as possible. Last year, we bent an intake roller, and we had a chain that showed signs of failure. It didn't fail, it showed signs of failure. And we got this dent right here. And that was the limit of our mechanical failures. So robust design is really important. And the way to have robust design is to have simpler robots with fewer parts so that you can make your parts stronger. Having fewer parts means it takes you less time to design them, it takes you less time to fabricate them, and there's less things that can go wrong. And again, avoid doing everything. The one thing that we said we were not going to do last year was lift partners with us, because we knew we were not going to have weight to do it effectively, or design resources to do it effectively. Questions on design methodology? Design according to your resources. I can't stress this enough. So, I've talked about this ad nauseum now. I'm not going to go on. Buy everything you can. Make only what you can't and are capable of making. Don't try to make some elaborate widget if it's well beyond the fabrication resources that you have. It takes a certain level of experience to know what you're capable and what you're not capable of. Again, that just comes with time, but we buy everything we can. We buy our drive gearboxes, we buy a bunch of versaplanetaries, we buy all our gears, we buy as much stuff as we can, and then we make what we can. Order parts early. I talked about this again. The network of COTS manufacturers in FIRST is fairly limited, so if you know there's going to be a run on Mecanum wheels. Buy your Mecanum wheels early. I don't know. Whatever it is. Pneumatic wheels was a really good example because a lot of teams got hosed by that. Order parts early. Finish early and iterate. If you finish your robot a week before you go to an event and you realize something's wrong, you have no time to fix it. So finish early, make changes, figure out what you can do to be better. Be awesome. CAD everything or not. Remember your design resources. So if you're a team that has tons of CAD resources, really good CAD mentors, really good CAD students, yeah, go nuts, CAD everything. If you're not a team that has that, maybe you want to do some hand sketches, some paper sketches, some 2D sketches in AutoCAD. You got to remember, if you spend 3, 4 weeks, 5 weeks designing your elaborate robot and then you have no time to build it and debug it, was it really worthwhile in CADing every little detail up front? Probably not. So this is a decision that, again, every team has to decide for themselves. Does it make sense for us to CAD everything? Yes or no? And then maybe you only want to CAD your ball gripper, your mechanism, and then you're just going to use the kit drivetrain or whatever. So this is something that you got to decide for yourselves. Oops. Questions on design and decision making? Okay. So fabrication techniques, build to your resources. I've stressed this a number of times. Don't design a sheet metal robot if you don't have a sheet metal company lined up. Sheet metal is surprisingly cheap. If you were to just pay for it out of pocket, most teams would still be under budget. So, I mean, a lot of teams think, oh, we gotta have this sponsor to do it for free because the machines are millions of dollars. Well, to actually just buy a robot worth of sheet metals would be like $1,000 or something. So it's not actually all that expensive to just go out and find a shop and pay them to do it. Which is perfectly legal under the rules. The only thing you have to now cost account for, under the previous rules anyways, you have to cost account for the value of the material and labor that went into it. Which again is not that much. The delivery is tricky though. Most sheet metal shops will not turn stuff around in a week. So know your schedule, be conservative. Yeah, we've talked about all this stuff already. Some basic assembly stuff. Practice robots should be identical. This was more important during the bag era, where you had this one sealed up that you couldn't really touch. So we used to do all of our auto development, autonomous stuff on our practice robot, and then we'd just take that code and copy it over. And almost always, it would work. A lot of teams struggle with that because of minor differences in setup between the two robots or minor differences in sensor mounting or whatever it is. Now that we can all keep our competition robots out, this is much, much less important. Take the time to fit your parts nicely. In the event that you do have a mechanical failure and you need to somehow get this thing apart and figure out what's wrong with it, if you didn't have to hammer it together the first time, it's going to come together a lot easier the second time. So specifically on our competition robot, we take a great deal of time and care to make sure that all of our parts fit together nicely, so that if they ever do have to come back apart, we can do it without getting out a hammer and a press and trying to get stuff apart. We're big on standardizing fasteners. Pneumatic fittings, electrical connectors, solenoid valves. If you have to put thought into what solenoid valves you're going to use, that's thought that you are not putting into something valuable, like what your mechanism will look like. So we've standardized on as many things as we can so that we can put design effort into things that matter, and the rest of it that doesn't matter is just totally autopilot. So what solenoid valves we use, or what connectors, or electrical connectors, pneumatic connectors, whatever. Regulators, compressors, pressure gauges, that kind of thing. And the final, ask me anything, questions about anything we do on our team. Any questions at all? Why is there a cardboard cutout of me behind the wall? That is an interesting question.
You're always here.
I am always here so that the students know when they're practicing that I'm watching. No questions? Really?
Have you guys ever had any issues with, you guys use the small little pressure regulators and valves and stuff like that from Automation Direct. Have you ever had an issue in inspection with those?
Yes, there's a lot of inspectors that are really bad and don't know
I had
what
that
they're
at
doing.
Western this year and it was a pain.
Yeah. Yeah, I don't know what you do about inspectors that don't know what they're doing, and that's a problem in first. The regulator is perfectly legal within the rules, and
Only other question I have, with inspection related actually with you guys, when you guys go to a competition, are you asked at each competition to weigh in your spare parts?
we have been in the past, yes.
Okay.
Yes.
We ran into another issue at provincials where we hadn't because we weren't asked to at either of our other events, had forgotten about it, and then we're out a lot for using our spare parts at provincials.
Yeah, that's bogus.
Unfortunate, but yeah, I was just curious.
Yeah, no, we have been in the past, and it's whatever. I haven't fully digested most of the rules or new rules with the whole no bag era, but what you're allowed to bring in, what you're not allowed to bring in, because it seems very gray.
Yeah, it got more ridiculous.
Like you're allowed to bring in spare parts, but you're not allowed to bring in a robot. But there's a difference between a robot and a robot.
A bunch of parts that are partially assembled.
Yeah, so that's kind of messy. Like, I don't know how you ask an inspector to enforce that when they're so vaguely written in the first place. So, I mean, if it were up to us, we would just bring in 2 brand new robots and be like, okay, let's go. Oh, this one had a problem. Let's go with this one. And that's probably not what they're looking for.
It's pretty clear what the intent is. It's just how they word it so that.
Is it though?
I feel the intent is they don't want you bringing a second robot.
Yes,
like
I agree.
That's it. That's the intent that I see them coming with. How they're trying to word stuff is, like you said, very gray.
But that's a robot, and that's not a robot.
Well, it is. You've got a fully assembled drag base, don't you?
It doesn't have got no bumpers. It's not a robot.
Touché.
If I take one of the wheels off, it's also not a robot.
There you go.
Yes.
What's the biggest obstacle 2056 had to face, and how did you guys overcome it?
Ooh. Obstacle in terms of team development or design or?
Maybe in terms of competition and design.
That would be the 2012 championship,
Oh.
and I would prefer not to get into it, to be honest.
Yeah, that's not. What about 2016?
That was just heartbreaking. That was just heartbreaking. But what's really funny is like, we had played with the Beach Bots the previous years, and we're very, very. I have a Beach Bot sweater that I wore today. So to lose to them was like, I feel really bad, but I'm really happy for you at the same time. But I'm still heartbroken, and I'm really mixed about this. So yeah, we're really good friends with the Beach Bots, and we love that they won the last real championship, and that these like half championships are, well, half championships. So I'm actually going on vacation with the lead coach from the Beach Bots in a couple weeks, so we're quite good friends. We love the Beach Bots. Yeah. Still sucks though. More questions?
Would you ever consider going to Chesney Champs?
So far. It'd be cool, but it's super far. I might go personally, but I don't think we would take the team. It's just logistically to get out there in the fall during the school year. It's like to drive would be 4 or 5 days, and then 4 or 5 days back, and it's like to fly would be outrageously expensive. We don't have the budget for that. Yeah, it'd be cool, but probably not. More questions? Okay, well, if you guys have anything afterwards, feel free to stop by and ask. Thank you for being a wonderful audience. Enjoy the rest of your afternoon.